Segment from a vertex of a triangle that is perpendicular to the opposite side is an altitude. We're not doing it. You can also call it a height. And every triangle has 3 altitudes. So you have your traditional altitude comes straight down to the side, but we also have an altitude coming from here. Why did I do that? To probably about there, if that was 90 degrees. And then we have another altitude that goes from here to there, if that was 90 degrees. So I'm not 100% certain I did that correctly, but every triangle has 3 altitudes. The right triangle similarity theorem said that in a right triangle, the altitude divides the triangle into 2 triangles that are similar to each other and similar to the other triangle. And we've already used that. So if we have a right triangle, we have a right triangle and we have an altitude. Okay. Then this triangle is similar to this triangle, which is similar to the big triangle. So the 2 small triangles are similar and the large triangle, so all 3 are similar to each other. The length of the altitude to the hypotenuse, so that's right here, is the geometric mean between the 2 segments on the hypotenuse. So if you take this segment and this segment, this is the average, geometric average of them. And in a right triangle with an altitude to the hypotenuse, each leg is the geometric mean between the length of the hypotenuse and the length of the segment that is adjacent. So this leg is geometric mean to this part, this leg is a geometric mean to that part. It'll make sense in a minute. Okay. All right. When a, b, and x are positive numbers, ax is equal to x over b. This is the geometric mean. Okay. So if I want to find the geometric mean between 4 and 9, I put 4 over x is equal to x over 9. And then I solve for x. So I cross multiply. And I get x squared is equal to 36. I take the square root of both sides. So x is 6. Okay. All right, so in a right triangle, the altitude to the hypotenuse, so if this length here is the hypotenuse, this is our altitude, divides the triangle into 2 triangles that are similar to each other and similar to the original triangle. So we have WXY, that's the original triangle, is similar to WXZ, is similar to XYZ. So big triangle is similar to medium triangle is similar to little triangle. We also know in the right triangle, this is from that theorem that didn't make a lot of sense, if we make this altitude and we take the segments that it causes, that altitude is the geometric mean where we had x before. So if you take the long one over the long leg over the altitude is equal to the altitude over the short leg. So there's the long part, not leg, sorry, segment. So there's the long segment over the altitude is equal to the the altitude over the short segment. This gives you this would be the geometric mean. And we can use this if we have one of the heights, like if we have this altitude and we have A, we can find B, or if we have A and B, we can find the altitude height. Like we can find the missing, if we have two, we can find the third. Exactly, same thing. Okay, so we have the altitude to the hypotenuse is here, and we have x, y, and z. All right, so what we can do is we're going to have to do a little bit of work on this. Hold on one second. So we're going to use triangle similarities to find these. 12 and x are in proportion, and 6 and y are in proportion, and then you can use z, and 12 and x are also in proportion. Sorry, 6 and y are not in proportion. 6 is in proportion to the height, right? Because if this is one of my right triangles, this is the short leg, long leg, short leg, long leg. Okay, we're going to need to use a geometric mean, but we've first got to find this height, and I think these are in the wrong. Okay. We have z is the whole hypotenuse, and we have 12 and 6. I was forgetting that the leg to the segment, 12 is the geometric mean between z and 6. Okay, that we have this here. Each leg is the geometric mean between the length of the hypotenuse and the length of the segment of the hypotenuse adjacent to that leg. So if we come here, 12 is the leg. Here's the segment of the hypotenuse adjacent to the leg. So 12 is the geometric mean between 6 and z. So if I put so I would say z over 12 is equal to 12 over 6. Because 12 is the geometric mean between 6 and z. So I'm going to cross multiply this, and I get 6z is equal to 144. Divide both sides by 6. Oops. Divide both sides by 6. Did you already do it? Oh, what was it? 24? And you get z is 24. Okay. Yeah. So if I have 6 and I have y, make up 24. Y is equal to 24 minus 6. So that's 18. Okay. Now, if 12 was the geometric mean between 6 and z, x is the geometric mean between 18 and 24. No, we're going to do 18 over x is equal to x over 24. We need our x's to cross multiply together. We could do x over 18 is equal to 24 over x. It's just we have to have the x's cross multiply because they're the geometric mean. Okay, so cross multiply here, and I get x squared is equal to, 432. And then I'm going to take the square root of both sides. Okay, so 20.78, so we're going to do 20.8. Finding the geometric mean between two numbers, we do 4 over x is equal to x over 49. Now I'm going to show you a trick. See how this is a perfect square? And this is a perfect square? Mm-hmm. Don't actually multiply that together. I get x squared is equal to 4 times 49. Because when we take the square root of a product, it equals the product of the squares, or the square roots. So x is equal to, the square root of 4 is 2, the square root of 49 is 7. It required less work on my part because I didn't have to multiply 4 times 49 and then take the square root of that. Because I knew 4 was a perfect square and 49 was a perfect square, I just took the square root of each individually and then multiplied them together. Does that make sense? Okay, now here that won't really work. So I have 5 over x is equal to x over 32. So x squared is equal to, what? Wait, 160. Take the square root of each side. Now here's the complicated ones. All right, first C, I have BD is 6 and CD is 12, and I want to find DA. 6 is the geometric mean between x and 12. Okay, so I'm going to do x over 6 is equal to 6 over 12. 12x is 36, so x is 3. And I have CA is 16, so this whole length is 16. And then CB is 12, and I want to find CD. Now, 12 is the geometric mean between x and 16. Okay. And I can reduce this if I want to make smaller multiplication.
I'm being a good boy.
6 over 8, which would be 3/4. So I have 4x is equal to 36. So x is 9. We'll do this. Let me... No, not that. I don't want to do that. Oops. No, I don't. Draw my own triangle. Okay. Actually, I'll do this all black. Okay, So this is our altitude to our hypotenuse, right?
The hypotenuse is the birthday.
The long line.
Yes, yes, yes.
Yeah. Okay.
My mom is good.
Hold on, let me think about how to color code this. I think maybe using colored letters might be the way to go. If this length here is X, I'll make this Y. I'll make that Z. Oh, that's not different color. Make that Z. Okay. So this Y is just this short part, X is this short part, Z is the altitude. And then the lengths, the side lengths of the main triangle, A, B, and C. Okay? All right, so we have okay. So A is the geometric mean between Y and C. So Y over A is equal to A over C. Okay. B B is a geometric mean, and it's the geometric mean between X and C. And then Z is a geometric mean between Y and X.